Hello, everybody, and welcome to Sparing Partners. Today I have Azita Arvani as a guest. She's a repeat guest and a friend of mine, so I'm very happy to have her here. And guess what? We're going to talk about AI. But what we're going to do is to talk about it in a different perspective. So, many of the podcasts have been either on AI or some topic related to it. And today we're going to sort of take maybe a little bit of a step back, but to talk about how pervasive is AI is going to be in the short term, in the long term. And at this point, nobody's going to question that AI is going to become central in telecoms and elsewhere. But we're going to talk about telecoms. The question is, how should we go about it? Should we just gradually introduce it? Be very, or how aggressive should we be? Should we think about as a tool that help us in what we do, or a radical transformation that requires a step function? And as we were talking about this earlier, Azita and I talked about, is AI something more like salt that you put on food to make it taste good, or is it just its own ingredient that changes the whole nature of what you're cooking? And so we're going to talk about that. And so, Azita, thanks a lot for being a repeat guest. So not just a guest, a special guest.
Thank you, Monica. It's really great to be here and to talk to you about topics that are very relevant and important for telecom, and in this case, telecom and AI intersection.
And for those of you that didn't listen to the previous one, I recommend that you go and listen to the previous podcast with Azita. But if you haven't, Azita, why don't you tell us what's your background? You had a very cool. I think I said last time you had the jobs that I really. It's just like I wish I had those jobs. You're really cool. You were so lucky.
Oh,
No,
thank
no, not lucky. Obviously, you were talented to get them, but at the same, luck always helps too. So tell us
Absolutely.
what you did and what
Thank
you're
you.
doing.
Thank you for that. So all of my career has been around bringing emerging technologies to the market. Initially in developing it as software developer in networking and databases, and then later in telecom for over 2 decades, different parts of the stack. I've had my own company for a while, working with amazing clients like Docomo and Microsoft and a lot of startups. And then with Nokia as head of partnership and alliances, and also head of innovation partnering and venture management. And then most recently with Rakuten Symphony as the CEO of Rakuten Symphony Americas, which I greatly enjoyed all of those roles. And as you said, it's a privilege to have those kinds of roles because it's always about leading edge of technology, sometimes the leading edge of the technology, and then bringing him to market. So I have a big love for telecom and of course for AI as well. And now I work at the intersection of telecom and AI with big companies as well as a lot of startups.
Yes, and obviously, I mean, this seems like the natural thing to do for you to just try to understand what's the impact of on AI on telecoms, since you know both. And so, okay, so and you just wrote a paper that is going to be linked in the description of the podcast, so people can read it, and I do recommend you read it. So. Okay, so let's talk about it. So, okay, as I said, AI, everybody agrees AI is important. How should we think about getting into the networks? Because clearly it's not yet mature, it's not 100% there. But we don't want to be waiting until 100% there because that's too late. So, how should we start thinking? I mean, how should we think about it? Because we don't want to overdo it, we don't want to underdo it, and we also need to understand it's a long-term thing. So how should we go about it?
Yeah, so the name of the paper right now, the working title is Beyond Connectivity, and actually I'll just read the whole the it's Telecoms AI Driven Future in 5G Advanced, because as you know, we're at the midpoint of 5G, so we're just getting into 5G Advanced. The 3GPP release 18 is just come out and people are starting to move into 5G advanced. So the way to think about it is that obviously AI for every industry, including AI for networking, is a huge fundamental transformation, and that brings a lot of value. And so that's something that, of course, all of us in telco are supporting and moving it forward. But the other part of it is that telcos are at really a prime position to take advantage of the assets that they have and the capabilities that they bring beyond just connectivity that can help AI in every industry. So this notion of it's not just AI for networking, but networking for AI. What can networking do for AI? And so that goes, benefits go from, of course, the high speed connectivity, like in 5G advanced, we're talking up to like 100 gigabits per second. We're talking about finally reaching that ultra reliable, low latency communications that we've been talking about a lot, like 1 millisecond type of a round trip latency. We're talking about extended coverage, being able to support many, many nodes. And then also being able to have non-terrestrial networks, right, with satellites, whether it's geo satellites, LEO satellites, other kinds of satellites. But in addition to all of that, telco radio access network has a distributed network all over the geography that it covers. And this provides a lot of opportunities for bringing AI closer to where AI needs to be inferenced and potentially even be trained. So this would be telco cloud having multiple edges, whether it's the central, which is the traditional model, or having cloud at where the base stations are at the far edge, or at the near edge, or even if you have a private network, have it in a private edge, and then even have collaboration with the device AI, right? With the AI that's having on the device. So these are all the benefits that telco can bring to AI in every industry, besides taking advantage of AI in its own industry as telco. So I think that we should think about this as a very special place for telcos to be in AI economy, besides lowering the costs and having some AI services for the normal customers. In addition to that, you could bring AI services and AI platform in a distributed, trusted way to other enterprises so that they can offer AI services to their customers.
Now, I often, talk more about the AI in the RAN, but you bring very interesting issues here in terms of making the network ready for AI to be adopted by others. So it's kind of a little bit more. It's not just putting AI in your network, but making sure that the network can support whatever the enterprise out there needs to do. Do you
Right.
think that operators, and I guess secondarily vendors too, are aware of what is that those enterprises need? Because you made a list, so it's like you need to be closer to the edge. You need to be, provide the latency that, all those things that AI requires. So AI processes in different verticals require. And I would say that traditionally operators have not been very good at understanding what the needs are. So, even if the network can support those things,
Right.
if you don't think you don't pick and choose correctly and wisely, you might end up spending too much money or not enough or not offer the right services. Do you think that the operators and the vendors know what's needed and what's more important, what to focus first? Or
Yeah, that's the great question, and that's really at the crux of this. But what operators do have are assets that are at these edges. They are there located right now. So what a traditional network operator has is computing at the, let's say, at the far edge. Let's just talk about the base station for a minute. So at this base station, you have a baseband that's running on a proprietary hardware, right? Because it's a proprietary hardware, you don't have open APIs, you don't have SDKs and a development environment for developers. People will be hesitant, like you can't really write a application that runs on top of it. And generally speaking, these compute resources, even if it's proprietary, are provisioned for maximum for peak loads at that base station, right? So, uh, like conservative estimate is 50% of it is not utilized, right? But in reality, it's more like only 30% is utilized. So it's somewhere between 50 to 70% is unutilized compute that's just sitting there. So, but if that compute was a general purpose compute, right? Whether it be CPU or a GPU sitting there. And not only it was running the telco workloads, but it was open for other people to use. So then you would think that, like, intuitively, it would make sense. I have this extra capacity that's sitting here. Why not share it as part of some other compute infrastructure? So in this case, we are talking about AI infrastructure. Why not make it as a pool of the AI infrastructure? Now, you say, like, do we know what kind of services people would want to use and things? And I think at this point, this telecom vendors don't need to necessarily know the AI services themselves, but they need to know which companies would need that. And the most of us think that inference is going to be everywhere, right? So, and it's going to be distributed. And instead of taking all the data from wherever it's collected all the way to the central cloud, which is expensive, and then get the answer and the inference and prediction and take it back to that edge, why not just process it right there at the edge? So telcos have the assets to be able to offer that platform, but only if it's in a context that's usable, right? So in the context that I have aggregated my workloads in a way that's sitting on top of a general purpose compute, and that compute I can make it available. So I have open APIs that can take advantage of what telcos offer, and I'm letting other people come in a secure, confidential way to be able to use that compute infrastructure.
Yeah, and I think that, you keep talking about the edge, and it's a really important issue because, when you think, and especially when you think about, LLMs and the way we use it, I mean, as a individuals,
Yeah,
not in telecoms, most of it is like very centralized infrastructure.
right,
So I do my query, God knows where it's processed, it doesn't matter to
right,
me
right.
because of the kind of thing, right? But for some of the things where actually latency matters, physical distance matters,
Yeah,
like very old, it's nothing to do with AI. This is
yeah,
like it's physics.
yeah,
And so, actually, operators is not just the base station, but they also have a lot of central office location in very central places, which can be used for that purpose. So
exactly.
it's really important. It's assets everywhere. The question is to
Absolutely.
understand.
Right. So yeah, absolutely. Yeah, took the example of the far edge with the base station just to kind of make a
Yeah.
point. But you're absolutely right that those far edge locations, then you could also have like near edge, if you will, locations. And then you have the central locations, right? You have what we used to call central offices, right? Those central offices could
Mhm.
also be made into AI factories, if you will, or AI data centers that could not only handle like the packet core that's sitting there and the non-real-time parts of the telco workloads, but also be used as some people for like sovereign AI or just AI in general, right?
Yeah. So there is a much, it's not just AI or not AI or central versus edge. There is all sorts of in between.
Yeah,
And I think
absolutely.
that that's what makes it so exciting because there is so many things you can do
Yeah,
depending on who you are, what you're trying to do. And so it's not going to be a script, a
absolutely.
simple
Yeah,
recipe that works for everybody. So I think that this I think it's a, quite interesting because we should think, I mean, again, AI is all sorts of, models and whatever that can work in theory everywhere, but sometimes you do need to have them run in a special place or a special distance from what you're trying to do. So it's not,
Exactly. For a variety of reasons, right? You
yeah,
mentioned latency is a big deal. The other one is about privacy and security. Maybe you
yes,
don't want it to leave where it was generated, right? So then you could do the inference there. So yeah, so there's a lot of things that can happen there. Obviously, when you called it like AI as salt, the AI for the RAN itself could happen there at that edge
Mhm.
as well. Like for example, if you want to increase the efficiencies and like improve the energy usage at that site. You could do it, or if you want to use it for interference management, you could use it there, optimizing mobility. But those are all the AIs for telcos to be more efficient. But
Yeah.
then, in addition to that, the other side of the coin is uh, providing a platform that other people could do a lot of interesting things with. Like we can come up with some examples, but I think once that platform is offered, the customers can be much more creative with what can happen there.
Yeah, absolutely. And sort of following up on that, there is a question of hardware. So again, AI is going to be there, it's going to be pervasive. Everything we'll do is going to be AI based. And okay, but there is a question that is coming up more and more is you can do some basic AI in any hardware, and you can do some on. So you don't need GPUs, you don't need hardware that is optimized for AI. But at what point should we switch? Because you don't want to throw away what you already have. You want to use it to. So, how should we think about it in terms of when you switch?
Yeah, so I think that even if you want to get to just AI for networking, to get to a more advanced level, to be able to go across the domains, like not just stay in the RAN, for example, or stay in the core, like not just AI for the core or AI for the RAN. You need to be able to have this cloudified network functions. Of course, cloudifying a core function is much easier than cloudifying a RAN function. But
Mhm.
eventually, all of them need to be cloudified. So you can take advantage of this notion of microservices, containerization, and also orchestration, right? So then your underlying hardware becomes more of a standard, again, general purpose compute. So then you can orchestrate these things, move them around as needed, and then be able to offer it to others. Now, when should that transition happen? I would say that, of course, you have a big network. It doesn't have to happen right away, but the vision has to be there. So as you're going through um, like 5G advanced release, now we finalized release 18, but in release 19 and 20, and as we get into 6G, which is starts with release 21, this has to be top of mind. And given how fast AI moves outside of telecom, like these things also need to be moving very fast. It took us a long, long time, and you could even argue that we're not still there, going to Open RAN, right? Like, but that shift to having cloudified network function uh, everywhere especially in RAN, that has to happen sooner rather than later. And it cannot just be with POCs. Like we've been in this POC purgatory for a long time. It has to go into deployment and it has
Mhm.
to scale as quickly as possible. Again,
Mhm.
I don't expect it to happen overnight, but it has to, like, let's say it could start with small pockets. Certainly for private 5G networks, it's a great start to go there and start with that. But over time, as new investments come in, those new investments should over-index on the side of cloudifying network functions.
But you need GPUs everywhere.
Okay, so that's a very interesting question because uh, I know as someone who's been in this Open RAN journey, how hard it was, and it still is, to go from a proprietary software hardware combo to having software running on top of CPUs, right? And CPUs are have been around for longer for telco workloads. Now, moving it all the way from proprietary to GPU, that's a big leap. Um, it could happen, but I think pragmatically, it'll probably be in two steps where it's like you're going from um, proprietary hardware to maybe CPUs with some GPUs for AI, and then from there, maybe to GPUs only, right? Like that. Because moving to GPUs only, I think it's a big leap. And there are so many features in 5G, and we saw that in Open RAN, right? Like in order to be able to bring all those features into Open RAN and mature the product enough so people feel comfortable with transitioning. It could happen, but I just think that it needs a lot of support from a lot of ecosystem players.
Yeah, and I guess that, given that operators are under tight financial pressure, might be overkill. So, okay, so I see that, okay, as I said, AI is going to be there, period. But I see two possible bad scenarios here. It's one where you kind of progress so slowly that you kind of muddle things, but you don't really take advantage. And then you say, well, yeah, it wasn't really all that good after all, because let's see, not too much of a change, which is what happened a little bit with Open RAN, because people just, didn't do much. Or you might have a different situation where you go with it full force. That's unlikely to happen in telecoms. We know that, but it's a possibility, right? So that people are too aggressive and then they fail because AI is not mature enough because everything is evolving. So you go in there too quickly and then you say, see, it didn't work. I spent all this money and then, which is more like the 5G kind of line of that some people say, well, see, we didn't get any money from 5G, so 5G failed. And I completely disagree with that assessment. But you could have both things happening, which are not
Yeah,
designed. How
right.
can we avoid that?
That is fair. However, if you look at the history, right, like even with the network function virtualization, software-defined networking, we started working on that in like 2011, and the real deployment didn't happen until
Yeah.
2020, right? And so it took a decade to get it deployed, and you could still argue that it's not uh, taken the telecom by storm, but so over indexing on going too fast to me is a better route this time because we tried this slow route before and that's not that has not created new revenue. If anything, we have, as a telecom industry, we've offered an amazing connectivity platform where other people have started taking the bigger chunk of the value. So I think I would bet my money on let's overspend this time. And just looking at what other people are spending in this whole area, it's like you couldn't go wrong. I mean, look at what's happening with CoreWeave, right? Offering AI data centers and how popular it's become, or similar, or hyperscalers with offering AI services. So I, of course, there's always a chance that people might not get it right, but it's certainly not because of lack of demand. I think it would be more like in smart implementation of it.
Yeah, I mean, I guess, you have a great point that, as an industry, we're not moving at really fast. Although, okay, I have to say that when you look at other industries like transport or utilities or whatever, it's not just telecoms. I mean, there is a little bit of because we often compare ourselves to IT.
Right.
where things are a little bit faster, but a lot of verticals are even slower. So it's not really.
True. However, I would argue that transport infrastructure is not going to offer this AI cloud services to other people um, based on a platform of very strong connectivity. But telecom does have that, right? We have a very strong connectivity layer. We're offering low latency. We're offering satellite connectivity. Fixed wireless, fiber, you name it, all kinds of connectivity. And then we're adding sensing and 5G advanced, so network as a sensor. In addition to that, if we can aggregate our need for compute and put them in a way that's offerable to third party enterprises that want to are dying to get um, AI compute for inferencing in distributed places. It's a different equation than other industries.
Yeah, and I think that this is an important point. I mean, the fact that others are slower doesn't matter. But it is true that we are in telecoms in a special position because we are enablers. No matter how you look at it, it cannot be otherwise. Because the whatever you do with AI, it just wouldn't happen if there were no connectivity. I
Absolutely.
mean, it's like I'm stating the obvious in a way, but I think that sometimes we forget about it.
Absolutely. I gave a talk at MIT AI conference in April of 2024, and I called networking as AI's third pillar, right? Like if you think,
Yeah,
data is the oil, and if you think that compute is the currency of AI, right? For compute and data to come together, you need networking, right? Like,
yeah,
uh, and that networking could be at the far edge, at the central, or whatever. But that networking has to be there. And even if you look at the scaling out in NVIDIA servers and things like in Dell servers that have lots of NVIDIA stuff, the networking backbone is super important, right? To be able to bring all that data to compute. So now we're looking at it as big networking, uh, nationwide or globally. So that's why I think networking, as you mentioned, is super important, and people are realizing it more and more.
yeah, and it's more important. As sort of we should realize that as you said, the edge versus center becomes really crucial. So it's not just connectivity is not just one thing you either have or not have. What
Right.
kind of connectivity you have?
Exactly.
Because what you need to do, I mean, so security is one issue, but the other issue is that everything happens in real time.
Right.
And about
And
real
that
time is
quality of
yeah,
service that you need, right? Like
yeah,
we're finally getting to places where network slicing is becoming a real thing.
yeah,
So what kind of slice do you need? How fast what kind of latency you need? What kind of reliability you need? All of those things can be dynamically allocated for your
yeah.
slice.
Yeah, and I think that, I mean, you talked about it, but I think that generally in the industry, we do not really think so much about it or as much as we should in terms of, what kind of connectivity you need and, really think it through. So it's not just putting AI or whatever data center. Okay, you need data centers, fine, but what kind of data centers? What kind of, and I think that, you see obviously the hyperscalers and I mean, clearly there is growing awareness, but oftentimes we tend to skip about all of those, which is actually the strength because we can provide differentiated.
Absolutely. Absolutely. Like because if you were just doing central AI data centers, so you're going directly in competition with hyperscalers and others that are offering that. Yeah, I mean, you also have a chance because God knows there's a lot of demand and there's room for a lot of players in here. But now you have this distributed network, which and as we go more from the training era of AI to inference of
Mhm.
AI era, and more industries are using AI, this distributed network becomes much more valuable
Mhm.
for different industries. So yeah, I think that that is super important to realize. Um, and then one other thing I wanted to add is that the what we are doing today with 5G Advanced in releases 18 and 19 are more what we have called in the paper, my collaborator and I, data-driven operator or data-driven network. So basically we have like network data analysis function, which collects data from different places, analyzes it and so forth. So we have that. We have management data analysis function and so forth for managing these things. But for the most part, things are staying within their domain. So to have this global end-to-end AI orchestration and lifecycle management and all that, you really need to get into this AI native era. And that is not going to automatically show up with 6G. We need to be aware of it now because 6G starts with release 21. So it's not like so far in advance. And yet to deploy that is going to be like by the end of the decade or so. So, and that's so much time in AI years, you know.
Yeah, absolutely. Yeah, because it's just moving so fast, and I guess it requires not just new technology, but a new approach to technology, the way that we people use AI. So it's not just AI for the network for AI, but also the people and AI. How do we think about it? How can we learn to incorporate it in our culture and structure so that we can use the technology to our advantage?
Mhm.
It's not just a question of technology, it's not just a question of money, it's a question of becoming comfortable with it.
Right. And then there's a governance around AI and
Yeah,
governance around data around AI.
yeah.
Right? So, and obviously, telcos are regulated industries, so the governance becomes a big issue that they have to deal with. But at the same time, the value that it has for telcos is the trust that people have with telcos, that you know that your data is safe and secure with telcos, right? More so than with um, other entities that might be doing a similar thing.
Okay, our time is up, but we have so many more topics to talk about. So maybe the next time we will talk more because we didn't really talk much about like the standardization issues and all, like sovereignty issues, all the other stuff. So we have plenty to talk in another one, and I'm sure we can do some more, and it would be great. And in the meantime, for you guys. Listening to us, do get and read the article, the paper from Azita. It's a great overview of what's to come. So
And
Azita,
just a little
yes,
addition, the paper is by myself and a great collaborator of mine, Mick Ito, who's we've known each other for 20 years now. And he used to be the head of R&D in Silicon Valley for Docomo. And now he's a professor at Osaka University and still very involved with telcos. And so just wanted to put that in as well.
that's right. We need to acknowledge everybody. Well, Azita, thank you so much for being a wonderful guest.
Thank you, Monica. As always, it's a pleasure to talk to you.
And thank you all for listening in. Do continue to listen, subscribe to the feed, and let other people know about Sparing Partners.